Good evening, everyone. Am I audible?
Yes, sir.
Shall get started. Net capacitance. Yeah. So I think we are left out with one more subtopic, right? That we are supposed to complete. That is a concept that is based on capacitors and dielectrics. Is that right? Yeah. So shall we get started? So yesterday's class, what did we discuss? This was the last problem that we did. Yes. Now we'll discuss about the capacitors filled with dielectrics and conductors. Right. So when you fill a capacitor with a dielectric of dielectric constant kappa, then if you fill it completely, then what will happen to the capacitance? Initially, let's say when air medium was there, the capacitance is C naught. What will happen to the final capacitance? C dash will be equal to, if there is a parallel plate capacitor, right? Between which it is completely filled with dielectric, what will happen to the final capacitance? It will be kappa times C naught. Am I right? Right. Suppose if the same dielectric, instead of being filled completely, let's say, is occupying only the space T of thickness, right, between a gap of D, then what will be the new capacitance now? C dash will be equal to epsilon naught A divided by D minus T plus E divided by kappa. Does everyone know this concept or not? Does everyone know this concept?
Yes, sir. Yes, sir.
So where kappa stands for the dielectric constant, right? Now I have a question. So the topic is capacitors filled with dielectrics and conductors. If suppose in this scenario you replace a dielectric with a conductor, then what would have been the new capacitance? C dash would have been equal to, if I have a conductor of thickness T, what would be the value of C dash? It will be epsilon naught A divided by D minus T. Because what is the dielectric constant of a conductor? Anybody? What is the dielectric constant of a conductor?
Infinite.
Yes, it is not defined because it's not a dielectric material, it's a conducting material. Right? So spherical capacitor filled with dielectric is not a part of your syllabus. Now, having these basics in mind, we are ready to start solving the problems. Okay. I have one important concept to be discussed today. I'll tell you. So example 79, in a parallel plate capacitor, the capacitance increases from 4 microfarad to 80 microfarad on introducing a dielectric medium between the plates. What is the dielectric constant of the medium? You can do it in 10 seconds.
Sir, 20.
Correct. So C is 4 microfarad, C dash is 80 microfarad. So what is going to be the dielectric constant? C dash divided by C, which is going to be 80 divided by 4, 20. See, I wrote these steps only for the sake of exam, or else you just divide 80 by 4. If it is an MCQ question, answer is 20. Right? Shall I proceed?
Yes, sir.
Now see, there is a parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. So C naught. So whenever air is there, no, we'll put a naught. So as a subscript. So C naught is equal to 8 into 10 power minus 12 farad. The separation between the plates is now reduced by half, and the distance between them is filled with a medium of dielectric constant phi. What would be the value of the capacitance of the capacitor in second case? So can I write this as epsilon naught A divided by D? So how do I frame an expression for C dash? It will be epsilon naught A divided by, tell me. The separation with the plates is now reduced by half, and the space between them is filled with dielectric. So when a dielectric is filled, its capacitance increases by kappa. But what has happened? The distance has decreased by 2. Can I write it like this? So this will be equal to 2k into epsilon naught A divided by D. What is the value of epsilon naught A divided by D? So
8
2
into 10 to the minus 2.
8 into 10 power minus 12. So what will happen? 40 into 2 is going to be 80 picofarad. So the capacitance has increased by a factor of 10. Clear? Right?
Sir,
Tell me.
sir, when will we be using like epsilon naught A by D minus T 1 minus 1 by T?
So in this problem, if you see, the space between the plates means it is completely filled. When it is completely filled, C dash will be K times initial value. Whereas if it is partially filled, suppose they give you the thickness of the dielectric slab, then you will use epsilon naught A divided by D minus T plus T by kappa. They should give you the thickness.
Okay, sir.
Got it? Next. So this is the problem I wanted to explain. I want everybody to pay attention, okay? Listen, this concept is actually not there in textbook, okay? But this is a question that they ask most of the times. I want everybody to make a note of this point. Even if you know, listen to this again. So there is a concept called as effect of dielectric between the plates of a capacitor when the battery is disconnected and the battery is connected. Okay. So what is the topic? Effect of dielectric under what scenario? When battery disconnected and when battery is connected. So there are 5 parameters we can measure with respect to them. So initially, without dielectric, if I take it here, without dielectric as one of the columns. Okay. Wait, let me make it more clear. Is everyone paying attention?
Yes, sir.
No. So without dielectric, and this is with dielectric. So the concept of battery disconnected or battery connected is only in the presence of dielectric. It is not without dielectric. Okay. So without dielectric, if I call the capacitance to be C naught. 1 minute, let me find some other space. Okay, I'll write it here. So without dielectric, if I say the capacitance is C naught, with dielectric, when I say with dielectric, it is completely filled. The capacitance becomes K times C naught. So this capacitance, whether you have the battery disconnected or battery connected, it is still going to be K times C naught only. Is that point clear? Next is the potential difference. So if I say the potential difference without dielectric is V naught, the potential difference with dielectric will also be V naught. Listen to this carefully. When the battery is disconnected, right? When the battery is disconnected, it will become V naught divided by kappa. and the battery is connected, it will only be V naught. It is the initial value. Is this point clear?
Yes, sir.
Okay. So I'll tell you how to remember this. If you remember this, right, you can recollect all the other parameters. See, suppose you have your mobile phone, right? Let's say when it is discharged, what will you do? Obviously, you will plug it into a charger, right? When will you remove the charger? That's an obvious question which I asked. When are you going to remove the charger as a user? Only when the battery is 100% filled. Is it right? Now, even after the battery is 100% charged, if you're still keeping that, if you're still keeping the charger plugged in, what will happen to the potential difference? It will still show you 100% only, no? You're able to understand, or is it going to decrease? It will still show you 100%. So that is the meaning. When 100% is reached, if the potential is V naught, when you keep the battery connected, it is still going to show you that 100%. Whereas if you remove the charger and start using the phone, it will decrease by a factor of kappa. So have this in your mind. Only when you start using it without a charger, the battery is going to drain. The same logic. Right? So since now you know these 2 points, tell me, without dielectric, if the charge is Q naught, then with dielectric, battery connected and battery disconnected and battery connected. What will happen to this? So what will happen to the charge when the battery is disconnected? So we know that Q is equal to CV. So when the battery is disconnected, you will have Q is equal to CV. What is the value of nu C? That is kappa times C naught into what is the value of nu V? It is V naught divided by kappa. So cancel them. Answer will be C naught V naught. What is C naught V naught? It is the initial charge Q naught itself. Because Q naught is what? C naught into V naught. What about battery connected? What will happen to the charge?
Kappa into Q naught.
It will become kappa times Q naught. Very good. Now you can tell all the parameters, right? What will happen to the electric field? If the initial electric field is E naught, right? E is directly proportional to V. Okay, E is directly proportional to V because of the potential gradient. So when the battery is disconnected, it becomes E naught by kappa. When the battery is still connected, it is going to be E naught. Okay. And the last point is about the energy. So initially, if I say the energy is U naught, when the battery is disconnected, what will happen to the energy? It will fall by a factor of kappa. When the battery is still connected, it will increase by a factor of kappa because U naught is equal to half C naught V naught square. So apply the value of C and V naught during the battery disconnected scenario and apply the value of C naught and V naught. Plug in the value of C naught, V naught when the battery is connected. You will be able to find that the energy will decrease by a factor kappa when the battery is disconnected. It will increase by a factor kappa when the battery is connected. Okay. This is very, very, very important. This table is not there in your textbook. It's not there in NCERT. But as I mentioned, problems will be asked, among which I'm going to discuss one of the important problems now. So if you're clear with this point, I'll proceed. Is there anyone who's not clear? Please let me know. Get it cleared, okay?
Sir.
Yeah, tell me.
Sir, in the first assignment that you had posted, there was some similar to this concept, sir, but it is a different concept. It's not in the textbook.
Which
Can
one?
you explain?
What is the
Sir,
question?
Some in first worksheet.
Is it the similar problem which I'm going to solve now? This one?
No, sir, no, sir. It's not this one.
Because this is a capacitor based problem. You please send me that, no? I'll look into it and I'll solve.
So that is not capacitor based, it's electric field based, but it is about dielectric. So
I'll definitely do it. You send me which problem. I don't remember the problem number. So if it is helpful, no, tomorrow's class, first thing I'll solve that problem so that it is helpful for others also, and then I'll proceed.
Okay, sir. Thank you, sir.
1 minute, guys. I need an extra slide. So, yes. I'm going to do this. Read this question very carefully, okay? Read it very carefully and then start solving it. Sorry. So in figure 2.123 shows two identical capacitors, C1, okay, it is not CJ, it is C1 and C2, each of 1 microfarad, capacitance connected to a battery of 6 volt. Initially, switch S is closed, means the battery is connected. Switch S is closed, means battery is connected. After some time, switch S is left open and the dielectric slabs of dielectric constant kappa is equal to 3 are inserted to fill completely the space between the plates of the two capacitors. How will the charge potential difference between the plates of the capacitors be affected after the slabs are inserted? Now, I'll ask you a sequence of questions, answer that. So, the switch being closed or open is going to impact which of the two capacitors present?
C2.
It is only going to be C2. For C1, what is the condition? C1 is under the scenario where it is always
Battery is connected.
It's always connected to the battery. So for C1, we need to apply only the battery connected scenario. So how will the charge and potential difference between the plates of the capacitors be affected after the dielectric is inserted? So tell me how to solve. So tell me the data, no? How do I even proceed? So V is how much?
Sir, when battery is connected, V0 is 6 volt, and this is also like the common potential difference is 6.
Yes, battery connected because they both, how are they connected? They both are in parallel. So the same potential difference will occur across both the capacitors. So this is going to be the potential difference across both capacitors. Am I right? No.
Yes.
So what is going to be the charge on the first capacitor? So what is the charge on the first capacitor?
1 micro.
C1 into V1, that is going to be
Oh,
1
sorry,
microcoulomb.
6. No,
Oh,
sir,
sorry.
6 micro.
Yeah, 6 microcoulomb. What about Q2? Q2 is
That is
also
also 6
microcoulomb when switch was closed. Correct? Because initially, what did they mention? Initially, the switch was closed only. After that, what is going to be the value of Q1 dash? Q1 dash is still going to be 6 microcoulomb, but what about Q2 dash? Q2 dash, after the dielectric is
2
inserted.
microcoulombs.
No, it's my mistake. 1 minute. There is a dielectric inserted, no? So after the dielectric is inserted, when the battery is connected, what will happen to the charge? So Q1 dash will be equal to kappa times C1 into V1. Correct. So it is going to become 18 microcoulomb. Am I clear, guys? If somebody is not clear, please get it clarified. Why I wrote that 18? Kappa is 3. C1 into V1 is 6. So 3 into 6 is going to give you 18 microcoulomb. Now what about Q2 dash?
0.
Why is it 0? It is not 0 because the dielectric is inserted. No. So once the dielectric is inserted, there is going to be some charge stored on it. No? What is going to be the value?
Sir, 2, is it 2?
2 microcoulomb.
2
2
microcoulomb.
microcoulomb. Yeah.
How did you get it? Because if you go,
Sir,
yeah, if
V
you,
naught would change, right? It will become V
yeah,
naught by kV.
yeah. So observe this table. When the battery is connected, it becomes kappa times Q naught. But when the battery is disconnected, it is still Q naught. So what will be the answer? It will not be 2. Rather, it will still be 6 microcoulomb only. I know it is confusing you. That is why pay attention. Did you all make a note of this table? So in this table, when the dielectric is inserted and the battery is disconnected, what is happening to the charge? It is the same as the initial charge that it had when the dielectric was not inserted. So what should be the
Sir, could
value?
you go back to the previous table, which the other table?
This one, huh? Potential
Yes.
will decrease. Potential will decrease. So is this table
Sir,
understandable?
then,
Tell me.
okay, sir, got it, sir.
Got it? Yeah. So what is the answer? It is 6 microcoulomb. Is there anyone having confusion on this? I want everybody to be clear with this. Is it clear? Why I wrote it as 6 microcoulomb, not as Q naught by K? Don't do that mistake. Because when the dielectric was inserted, the battery is disconnected for C2. When the battery is disconnected, the charge will remain the same.
Sir,
Ah,
sir, could you please write an additional step, kappa into C1 into V1 upon kappa?
sorry, come again. For
Sir,
which one
it
you
is
want?
6 because it is kappa into C1 into V1 upon
Oh, you want me to
kappa.
write like that and show? Okay. So battery disconnected. Okay, BD is battery disconnected with dielectric. Okay. What happens to the capacitance? Kappa times C naught. What happens to the potential difference? It decreases by a factor of K. So kappa times C naught into V naught divided by kappa, both cancel. It is going to be C naught V naught, which is the initial value. That is why I got it as Q naught. Is this what you asked me?
Yes, sir. Thank you, sir.
Okay. Now tell me, what is the potential difference between the plates of the capacitors in the new scenario? What is the potential difference of the across the plates of the first capacitor now when the switch is opened? It is same 6 volt. But what about the potential across the second capacitor?
2 volt.
It is, yes, it is 6 divided by kappa, which will be 2 volt. Is this point clear? See, if you want to practice this, I think there is another problem also in your exercise, NCRT exercise. There is a similar kind of a problem. You can try that also and see. But is the concept registered in your mind?
Yes, sir.
So if you're clear with this, I'll proceed. Shall I?
Yes, sir.
I think we have 2 or 3 more problems. We'll get it done. Do this. A parallel plate capacitor of capacitance 20 microfarad is connected to a 100 volt supply. Again, a problem based on disconnected. No, you're going to do. I'm not doing it. Okay, look at the table, solve it, memorize the table. So after some time, the battery is disconnected and the space between the plates of the capacitor is filled with dielectric. Nitish, you're there?
Yes, sir.
If you ask me a question, no. இப்போ எங்க என்ன யூஸ் பண்ணியிருக்காங்க ஸ்பேஸ் பிட்வீன் த பிளேட்ஸ் ஆஃப் த கெப்பாசிட்டர்னா இஸ் இட் கம்ப்ளீட்லி ஃபில்ட் ஆர் பார்ஷியலி ஃபில்ட்? அந்த செகண்ட் லைன் படிடா. Space between the plates of the capacitor is filled with a dielectric of dielectric constant 5. அப்படின்னா what are they trying to tell us?
Sir, fully filled.
It is completely filled. சரியா? அந்த டைம்ல what will you use? K times epsilon naught A by D. புரியுதா?
Yes, sir.
So have this in your mind and solve it. First collect the data and then approach in a systematic way. So can I give you 3 minutes of time?
Sir,
Tell me.
so the first one is 1000 joules.
1000 joule.
Sir, like, is it after the battery is disconnected or before?
Before. So they are asking, calculate the energy stored in the capacitor before and after.
Sir, but they haven't given the batteries disconnected.
It's given, no, it's here. After some time, the battery is disconnected.
So the second one is 200 joules. First part.
Did you write 20 microfarad? Did you apply the 10 power minus 6?
Yes, sir.
It's still getting 200. Okay, let me try and see. So parallel plate capacitor of capacitance. So C naught is 20 into 10 power minus 6 farad connected to a battery of 100 volt. After some time, the battery is disconnected and the space between the plates of the capacitor is filled with a dielectric of dielectric constant 5. Calculate the energy stored in the capacitor before and after the dielectric has been put in between its plates. Okay. So what will be the value of U naught? Half C naught V naught square. Half into C naught is 20 into 10 power minus 6 into V naught square is 10 power minus 10 power 4. 10. So 10 power minus 6 into 10 power 4. Sorry, 10 power minus 5 into 10 power 4 is 10 power minus 1 joule. Not, how did you get 1000?
Yes, sir. 10 power minus 1.
It is 0.1 joule. That is before. So after the
Sir,
dielectric is
then it'll be 0.02 joule.
Correct. So second case, what they are saying is after the battery is disconnected, right? The dielectric is put. So after the battery is disconnected and the dielectric is put, what does the table tell us? Battery is disconnected and the dielectric is put. The initial energy decreases by a factor of kappa. So second case, U dash will be U naught by kappa. It is 0.1 divided by 5. What you told is right, 0.02 joule. That's it. Am I clear with this? It's actually a simple problem.
Sir, can you do the second one using of C naught, of CB square? Like,
So U dash is equal to half C dash V dash square. Okay, va? So half into C dash evrada? Kappa times C naught
yes, sir.
into V dash evrado? V naught by kappa the whole square.
Yes, sir.
Then what I can write is half C naught V naught square divided by kappa. Va?
Q naught by K. Yes, sir. Got it.
Got it? Right. Shall I proceed? Thickness. I think there is a mistake. It is 0.01 watt meter. Okay, let's take in terms of meter and then do it. No? There is an electric field of 3 into 10 power 4 volt per meter, which is established between the plates. A 0.05 meter apart of the parallel plate capacitor. Okay, so distance between the parallel plates of the capacitor is 0.05. After removing the charging battery, an uncharged metal plate of thickness. So what do you mean by uncharged metal plate? What is a metal plate? When you see the word metal plate, what comes to your mind?
Capacitor.
Metal plate is a conductor. Huh? So when you insert
Okay,
a
two metal
conductor,
plates like this.
yeah, so two metal plates, capacitor is there. In between the capacitor, there is a metal plate of thickness 0.01 meter that is inserted. 0.01 meter that is inserted, right? Find the potential difference across the capacitors before and after the introduction of the plate. Can you? Shall I solve and show? So pay attention, listen. So electric field E naught is equal to 3 into 10 power 4 volt per meter. So the distance between the plates is 0.05 meter. After removing the charging battery, an uncharged metal plate of thickness. So thickness of conductor is how much? 0.01 meter is inserted between the capacitor plates. Find the potential difference across the capacitor before and after the introduction of the plate. So before introduction, can I say V naught is equal to E naught into D? Wherever you have uniform field, why is it so? Because E naught is equal to V naught by D. That potential gradient concept is there. No, instead of potential gradient, you can take it as V naught by D. Wherever electric field is a constant. So what is the value of E naught? 3 into 10 power 4 into what is the value of D? That is 5 into 10 power minus 2. So it will be 15 into 10 power 2 or 1500 volt. What is it? That is the initial potential difference even before the conductor was inserted. So after introduction of conductor, what can I write V naught as? V naught will be equal to, I want you all to think and tell me what would be a similar expression that can be written in terms of E naught and distance. It will be
So
E
E
naught
naught into T minus T.
Yes, it is E naught into D minus T. So 3 into 10 power 4 into d minus t is going to be 4 into 10 power minus 2. So it will be 12 into 10 power 2 volt, or it is going to be 1200 volt. Means there is a potential drop of 300 volt. Initially it was 1500. Now it has dropped to 1200. Am I clear?
Yes.
The point to be noted is battery is removed. So after the battery is removed, when you insert a dielectric plate, what is going to be the potential difference? So V naught will be equal to how much? E naught into d minus t plus E naught divided by kappa into t. Okay. So I'll explain this concept. Listen. If this is a plate of D, okay, and this metal plate is of thickness T, then how much is this distance going to be? It is going to be D minus T. So inside the dielectric, what is going to be the electric field? It will be E naught by
T.
kappa. Outside in the air medium, what is going to be the electric field? It is going to be E naught. So can I say that the total potential is contributed by E naught multiplied with D minus T plus E naught by kappa multiplied with T? Can I say it like this? So that is the reason why I wrote this expression. Check, they both are the same. Okay. Now see. So what is the value of E naught? So can I take that E naught outside and write it as D minus T plus T by kappa? So this will be equal to 3 into 10 power 4 into D minus T is 4 plus 4 by 2, that is 2 into 10 power minus 2. So how much will it be? 4 plus 2, 6 into 3. No.
1350.
1350 volt, no?
Yes, sir. No.
So 1350 volt. So leave this. You guys substitute and calculate. Tell me.
Sir, the first subdivision says like before introduction of the plate, right?
Plate means metal plate. ஏன்னா அதுக்கு தான் plate and they have given the name. Dielectric is called as a slab.
Oh, okay.
புரியுதா?
So it is not the dielectric.
Dielectric next step ல தான வருது. So another, you should always look at the subject, okay? Metal plate. So next time when they use the word plate, plate prefix பார்த்துக்கணும். Metal, it's a conductor. Dielectric na they generally use the word slab. புரியுதா?
Yes, sir.
Yeah. இங்கே questionல இருக்கு பாரு. If a dielectric slab is introduced in place of metal plate, they will ask like that. Shall I proceed? Maybe 2 more problems are there. 2, 3. And with that we are done. So where is it? So parallel plate capacitor is charged to a certain potential difference when a 3 mm thick slab nanadra, Nitish. Dielectric. Slab is slipped between the capacitor plates, then to maintain the same potential difference with the plates, the plate separation is to be increased by 2 millimeter. Find the dielectric constant of the slab. Slightly tough only. But right. So do it stepwise, okay? A parallel plate capacitor is charged to a certain potential difference. Let that potential difference be V naught. When a 3 mm slab is slipped between the capacitor plates to maintain, okay, there is a 3 mm slab that is introduced between the capacitor plate, then what will happen to the value of V naught? V naught will be equal to, can I write it as E naught into D minus, okay, can I write it as E naught into D minus T plus T by kappa, where that value of T is going to be 3 mm. Okay. Then to maintain the same potential difference, the plate separation is increased by how much? 2 millimeter. So V naught will be equal to electric field. They didn't do any change. Now, what is the value of new distance? It is D dash minus T plus T by the same dielectric kappa. Then find the dielectric constant. So equate these two. When you equate these two, E naught into D minus T plus T by kappa is equal to E naught into D dash minus T plus T by kappa. So how much will the answer be? I'm getting D is equal to D dash plate. So to maintain the same potential, the plate separation is increased by 2 millimeter. The plate separation, plate means a gap between the parallel plates. So it will become D dash minus
Sir, I have a doubt.
Mm-mm-mm.
Sir, if D changes, then T also changes, right?
T is not changing because it's the same thickness. No? Thickness of the slab, they didn't change. No? They told the distance between the plates has changed. Wait, they told to maintain the same potential difference. Okay. Now see, actually, V naught is equal to E naught into D. Listen to this carefully, okay? Listen to this again. So V naught is equal to E naught into D. That is the first statement. A parallel plate capacitor is charged to a certain potential difference. So V naught is equal to E naught into D. When a 3 mm thick glass slab is slipped between the plates, then what will happen? Potential difference will change. So it will be V naught dash. Now to make that V naught dash equal to V. Okay, now that V naught dash, to make it equal to V naught, what they are doing is they are changing the distance. So what I should write is, I should not equate these the second and the third values. Rather, I should equate the first and the second value. First and the third value. So E naught into D. Now what I'll have is D is equal to D dash minus T plus T by kappa. So this implies D minus D dash is equal to T by kappa minus T. So what is D minus D dash? The separation between the plates is increased by 2. Okay, I'll do one thing. Listen. I'll take this D to the other side, this whole thing to the left-hand side. So D dash minus D is equal to T minus T by kappa. So what is D dash minus D? It is going to be 2. Okay. So 2 is equal.
Sir, sir, which V naught is it, sir? You've written two V naughts. So different.
Which, see, first V naught is E naught into D term.
Sir, then the third one is also V naught.
Third one is V naught. That is the meaning. To maintain the same, see, actually what will happen is they've charged it to a certain value. Now, when you insert a dielectric, what will happen is the potential will drop. Because here they didn't speak about the battery. So whenever a dielectric is inserted, potential will drop. So to bring it back to the same potential V naught, what they have done is they have increased the distance between the plates of the capacitor by 2 millimeter. You're able to understand that point?
Yes, sir. Understood, sir.
That is why the third one is V naught. So I need to equate the first potential and the third potential. So d dash minus d is 2, thickness is 3. So 3 minus 3 divided by kappa. So which implies 3 by kappa is equal to 1. So kappa will be equal to 3. So this will be the answer. Check if there are no calculation mistakes. No, E naught will get cancelled. D minus D dash. So D is D only. So kappa should be 3. Shall I proceed? Let me see. See, this level of toughness will generally not go. Okay, actually, this is a good problem. So this one alone will do, and then we can wind up. Okay, so do this fast. The area of parallel plates of an air-filled capacitor is 0. So A naught is equal to 0.2 meters square, and the distance between the plates is 10 power minus 2 meter. The potential difference across the plates is 3000 volt. When 0.1 meter thick dielectric sheet is placed between the plates, the potential difference decreases to, so T is equal to 0.01 meter or 10 power minus 2 meter. Now the new potential drop is equal to 1000, decreases to 1000. Determine the capacitance of the capacitor before placing the sheet. So what is the answer? C naught is equal to epsilon naught A naught divided by D. So epsilon naught is
17.7 into 10 power minus 12.
17.7 into 10 power minus
12.
it's given 10 power minus 10. Check it. Divided by D.
Okay. Yes, sir. 10 power minus 10.
Yeah. So 8.85 into 10 power minus 10 farad. Charge on each plate. So Q naught is equal to C naught into V naught. So C naught is 8.85, 17.
Sir, you've
17.
written 8. Sir. Yes, sir.
So 17 into 10 power minus 10 into what is the value of V naught? It is 3000. That is 3 into 10 power 3.
Sir,
So
actually, it'll be 17 into 10 power minus 11, sir. They must have written it 1.7.
1.7 is 1.7 into 10 power minus 10. So it'll be 5.1 into 10 power minus 7.
And sir, it's actually 1.77, sir. So shouldn't be approximately 1.8.
Okay, I didn't calculate it. I just wrote 1.7. I looked only at the
Okay.
exponent. So that will give you a value. Okay. Those many times into 10 power minus 7 coulomb. Third is dielectric constant of the material. So how do you calculate the dielectric constant? Kappa is equal to new capacitance divided by initial capacitance. So what are the new capacitance that they are given? So new capacitance, can I write it as Q by V, and the old capacitance, can I write it as Q naught by V naught? So Q naught by V naught I already have. Now, when the dielectric, okay. Okay. So when the battery is disconnected, right? What will happen to the charges? When the battery is
It
disconnected,
remain the same.
they remain the same. So I can write Q divided by V naught. So Q and Q will get cancelled. Answer will be V naught by V. So what is the value of V naught? 3000 divided by the final potential is 1000. So it will be 3. So dielectric constant is 3. So what are the capacitance of the capacitor after placing the dielectric? So this 3 multiplied with this value will give you the new capacitance. What is the permittivity of the dielectric? So how do you calculate the permittivity of dielectric, guys? What is the definition of dielectric constant? Kappa is equal to
Sir, kappa into epsilon naught.
epsilon divided by epsilon naught. So epsilon is equal to epsilon naught times kappa. So 8.85 into 3 into 10 power minus 12. That will give you the permittivity of the dielectric. Right? So I hope it is clear. Today we discussed very important concept. Right? See, if at all they want to make it tough, they'll ask a question from this and you will get a sure shot 3-mark question. If you're not getting, well and good. If you're getting, you should not lose marks. Clear? So I hope you can handle it now, no? With this battery connected, disconnected, everything, you can do it. So at least give me some confidence by saying yes or no, man.
Yes,
You
sir.
can, yeah,
Yes, sir.
good. Okay. So we were supposed to start magnetic effects today. It got delayed by 2 days. It's fine. Still, it's worth discussing these concepts. So tomorrow's class, I'll start current electricity. Okay, if needed, I might take a slightly extended hour also. I'll not extend it by an hour, maybe by 20 or 25 minutes, I'll be extending it tomorrow. So I'll let you know by tomorrow. Okay, so be prepared for it. Because you have that for the upcoming part test, no, so I need to complete current electricity by tomorrow. Okay, if possible, revise all the concepts and come so that we can concentrate on problems. Okay. So is it all? Shall we wind up?
Yes, sir.
Okay. Perfect. Okay, I'll see you all
Thank you,
tomorrow.
sir.
Thank you, sir.
Thank you, sir.